In session 40 here, we're going to be addressing intercepts. If you take a look at the word intercept, you can see that it's very similar to intersection, and that's what an intercept describes. It describes the point on either the x-axis or the y-axis where a line intersects the axis itself. So a y-intercept would be the place at which the line intercepts the y-axis, and your x-intercept would be the point at which it intersects the x-axis. I've just drawn two arbitrary lines here, one in red and the other in a light blue. Right here is the origin. Now, visually taking a look at this, can you see at which point it crosses the y-axis? Remember, the y-axis goes vertically up and down the page, and your x-axis goes horizontally or across the page. So everything right here in the dark black is your y-axis. So at which point does the red line intersect that axis? Well, if you find your origin right here, you can see that it intercepts the y-axis 1 point above it. So the y-intercept would be 1. Now, coming down just a little bit further, we can also see now that at this point here, the same line crosses the x-axis. So the x-intercept here happens to also be 1. If you notice, at the point at which the red line, crosses the y-axis, that's called its y-intercept, what will the x value for that point always have to be? It'll have to be a 0. Remember, every point on a coordinate system like this has an ordered pair. It has an x coordinate and a y coordinate. Well, for any point that's on the y-axis, that's where x is going to be equaling 0. So if I came over here and I wrote down 0, 1, that's going to be the point at which it intersects or intercepts the y-axis. So when x is 0, whatever the value is for y, that's going to be the y-intercept. Likewise, for the x-intercept, what does the value for y always have to be at the x-intercept? Wherever any line crosses the x-axis, the y value has to be 0. So in this particular case, our x value is 1 and our y value is 0. This also is the x-intercept, 1, 0. Now let's take a look at the blue line, the light blue line. You can see it's going kind of at a different angle here. Well, let's address or answer the question, what is the y-intercept? Well, remember, for the y-intercept, our x value has to be 0. We'll come to 0 for x and then go up 1, 2, 3. 3 is the y-intercept. So the ordered pair for the y-intercept would be 0, 3. And if we were just to simply ask you, what is the y-intercept? The y-intercept is 3. Now let's find the x-intercept for that blue line. The x-intercept is going to be the point at which y is 0 and the point at which it crosses the x-axis. Well, here's our origin here. This time we're going to go left, or in the negative direction, 1, 2, -3. We can see here that our x-intercept is -3. And at that point of -3, for the x-intercept, the y has to equal 0. So that's a quick overview of your x and y-intercepts. And the reason why that's helpful is not only just to know where the x and the y-intercepts are, but it's so that we can also graph more quickly. Now I just went ahead and made that graph a little bit bigger here. The reason why knowing the x and y-intercepts can be very helpful when graphing a line is that in order to have a unique line, you have to have at least 2 unique points. So if we can just find 2 points, 2 ordered pairs that will work for this equation up here, we can go and plot those 2 points and then just connect it with a line, and that's our graph. But what's further, if we can make one of these values 0, we can then find the intercept of the other variable and then reverse it and make that variable 0 and then find the intercept of what comes before it, and then just connect those 2 points, and that becomes our line for the graph of that equation. So if we go ahead and make x 0 here, 6 times 0 is 0. That then just leaves us with an 8y equals 24. And I'm not going to go any further than this, but in order to solve it for y and get y by itself, we would divide both sides by 8. 8 times y divided by 8 would simply just be y. And then over on the right, 24 divided by 8 would be 3. So when x is 0, y is 3. So I'm going to go ahead and write that point down. 0, comma, 3. So let's come over here and graph that point. Well, 0 is our x value. That's at our origin. And then we're going to come up 1, 2, 3. So that then is our y-intercept. Our y-intercept is 3, and so the ordered pair for that point is 0, comma 3. Now I'm just going to go ahead and erase this. And what we're going to deal with now is the other intercept. The other intercept that we're interested in is where x is the x-intercept, where it crosses the x-axis. So for that to occur, what we need to have is a coordinate where our y is 0. Wherever it crosses the x-axis, y is going to be 0. So let's take that 0 and plug it up into our equation here. What's 0 times 8? Well, 0 times 8 is 0. So what that then leaves us with is 6x plus 0 equals 24. Well, what is 6x plus 0? It's just 6x. So after plugging in a 0 for the y, we are now left with 6x equals 24. And once again, I'm not going to write out the final step, but the final step to get x by itself, since it's being multiplied by a 6, would be to divide by 6. You would divide both sides by 6. 6x divided by 6 is x. 24 divided by 6 is 4. That then tells us that when y is 0, x is 4. So let's come over here. We start at our origin and come over on x, 1, 2, 3, 4, and then y is 0. So those are our 2 points. How many points do we have to have for a unique line? Well, we only have to have 2. So I'm going to come over here and then just draw a line that connects those two together. That then becomes the graph of that line. And once again, I'm not going to write the arrows on it here, but it's understood that this line does go on forever. It doesn't stop here. It goes on forever beyond the scope of what the graph even shows here. Let's take a look at another example. How about the problem 3x equals 12? How do we get an ordered pair out of this since there's no y in this equation? Well, we could go ahead and add a y without changing the value of the equation. And the way we do that, I'm going to rewrite the 3x, is we add a 0 y. Now remember, when we're adding a 0 times a y, anything times 0 is going to be 0. So by the fact of us sticking a 0y into this equation, all we've told the equation to do is add 0. And if we are just adding 0 to what we started with, have we changed anything? No. But to visibly see a 0y, it's now a little bit easier to plot some points here. So let's start. Let's make x 0. Well, if x is 0, what's y have to be? Well, we run into a problem here because y times 0 will never equal 12. Hold on to that thought a minute. And instead of making x 0, let's make y 0. And remember, by making y 0, we're going to find the x-intercept. Well, let's make y 0. What's 0 times 0? 0. What's 3x plus 0? It's just 3x. So then, we now have 3x equals 12. Solving for x, x would equal 4. So we now have 4 comma 0. 1, 2, 3, 4. We actually see that this has the same intercept as the line that we did just before it. However, when we stick a 0 in for x to try to find our y-intercept, 3 times x is 0. 0 plus 0y can never equal 12 because 0 times anything is 0. So we actually have a situation here where we have an x-intercept, but we do not have a y-intercept. How can that happen? Well, that can only happen if the line that we are graphing is parallel to the y-axis. In that case, it never does intersect or have an intercept with the y-axis. It's simply a vertical line that always has an x-coordinate of 4, but it never intersects the y-axis. So what would another point on this particular line be? Well, how about that point? If we were to write an ordered pair for that point, what does the x value have to be? It has to be 4, because in our equation 3x equals 12, x always has to be 4. Y can be anything we want it to be. In this case, it's 6. 4 comma 6 is a point on this line. 4 comma minus 5 is also a point on this line. Here's our x of 1, 2, 3, 4, and then we go down 5. Actually, I went down 4. 1, 2, 3, 4. And then here would be 5. So 4 comma minus 5. So we can see here that when we have a line that's graphed and it's vertical to the y-axis, it only has an x-intercept, and every ordered pair for a point that's on that line will begin with the x-coordinate of that x-intercept, and then the y can be anything else that you want it to be. Lastly, we can do the same thing, even though I'm not going to write an equation for it. We can do the same thing with a parallel line to the x-axis. If we have a parallel line to the x-axis, we can see that we do have a y-intercept. It's right here at 1, 2, 3. Our y-intercept is minus 5. However, we don't have an x-intercept. So what could a possible equation be here for this line? It could be as simple as y equals minus 5. X can be anything, and whatever x is, because remember we would just put in a 0x plus y, doesn't matter what that x is, because when it's multiplied 0, it's going to cancel out to be a 0. X can be anything. So if x is 10, y is still minus 5. If x is 0, y is minus 5. If x is minus 4, y is minus 5. So here then is a graph of an equation of where a line is parallel to the x-axis. When you have a line that's parallel to the x-axis, it never intersects the x-axis. Therefore, it only has a y-intercept. If you have a line like this blue one here that's parallel to the y-axis, it'll never intersect the y-axis. Therefore, it does not have a y-intercept. It only has an x-intercept. But the majority of all the other lines, in fact all of the other lines that are neither parallel to either the x-axis or the y-axis, will intersect the axis, both the axes, with a y-intercept and an x-intercept. Lastly, as a quick review, to graph a line, all you need to do is graph 2 points. Find 2 ordered pairs that satisfy the equation, and then stick those on the graph and connect them with a straight line. Your x-intercept is the location at which the line crosses the x-axis, and the y-coordinate for the x-intercept will always be 0. The y-intercept is the location at which the line crosses the y-axis, and then the x-coordinate for the y-intercept will always be 0. And then lastly, you can graph a line simply by plotting the x and y-intercepts, unless both of those intercepts are at the origin. In this case, you'll need another point. And once you have plotted the x and y-intercepts, you simply connect them with a straight line. Okay then, that finishes up session 40.